Hello and welcome to this particular session. I'm Juliet Woods. I work with Juna and Phillips University. We have an excellent lineup of talks between now and lunch. I know some of you are probably coffee deprived, as there was a coffee malfunction during morning tea, but I hope that will nevertheless not detract your concentration from these excellent speakers. We're going to start with Daniel Pearce. Thank you.
Hi everyone. My name is Daniel Pearce and I'm privileged to present on behalf of this excellent team of people who've been working on the model warehouse service. And I'd like to also acknowledge Matt Miles from the Knowledge Management Unit, who's been assisting us in recent times. So the aim of this talk is to give you an appreciation of this service that the department offers, really to go into some of the infrastructure, some of the processes that support some of the science which the department does. So there's a great deal of investment made into the use of models in water resource management. So I'll just briefly touch on why that is the case, and that will introduce us to this concept of having a warehouse, having some type of a system for managing this accumulating amount of knowledge assets. And there's some exciting things happening at the moment, so I'll talk through some of those things as well. So there's a wide variety of models that are used from, I guess, every problem we try to look at. We look at the conceptual underpinning of that problem, so some conceptual modelling. And then you might do some analytical modelling to see, test out some of your assumptions, your thoughts. You might even build a physical model, which sadly we don't do enough of. This is actually quite helpful for just communicating some of the complexities of water resources. But by and large, as you're probably aware, a lot of effort goes into developing numerical models. And these can be quite complex representations of natural systems that take a fair bit of work, expertise. And they're of great use to helping our policymakers make certain decisions around how we do manage our surface water and groundwater systems. So much of the questions that come up around what is sustainable in relation to our water resources, so a water allocation planning process, makes a great deal of use of models, of numerical models in particular. So I'll just remind us of a couple of examples of the significance of having these inputs to the decision-making process. Another example is with the River Murray. A great deal of work goes into looking at some of the salt movement into the River Murray, and numerical models are essential in understanding that better. So just giving us a teaser of some of the questions that come up. Northern Adelaide Plains, which has such significance economically in terms of the use of water resources. So the water allocation plan gives this entitlement of 26.5 gigalitres of water for use every year. And these come from a couple of aquifers in the Northern Adelaide Plains, shown here. So the question is, how confident are we that we can sustainably take up to that amount of water from this system? So over time, there's been a number of efforts to develop models to support this resolving this kind of question. This just gives you a cross-section through the northern Adelaide Plains and some of the predictions that are made by this particular model as to what happens at different levels of extraction. The Lower Limestone Coast water allocation plan has this allocation of 307 gigalitres, which is a substantial amount of water for commercial forestry. So being able to have that underpinning, that sense of security that this is the case, there's been a fair bit of work done, including the development of numerical models. And this is just showing some outputs from a groundwater model with a lovely cone of depression below some hardwood forests. So with the kind of questions that are coming up around water allocation planning, we're starting to see this question of what would happen under different climate projections becoming something that is of more and more concern. So, as an example, Barossa, where their water allocation plan has this amount of 3.8 gigalitres of surface water that is licensed, what would happen under different climate change projections? So again, the use of numerical modelling helps us to investigate these kinds of questions. And this is a fairly complex surface water flow model that's been developed. So I guess in summary, as we look to manage different resources, we can see the accumulating knowledge around how that resource operates being captured in these numerical models. So they represent a synthesis that are bringing together of various processes that are at play, and in that sense are a significant knowledge asset. And because we're often dealing with the same resource over time, we want to see how this knowledge asset is kept up to date, is improved. So hence the concept of a warehouse or a repository of these assets, these numerical models. Just to give you a sense of what the scale is, what we're talking about. Groundwater models in the department, there's been around 60 developed since '99. And you can see from year to year how much work has been put into this. Surface water, they seem to love their models even more. So this is, the last 5 or 6 years, a large amount of different types of numerical models are used in questions to do with surface water management. So, as I explained, in dealing with the same system, we often find we want to update or upgrade our models to see, with additional data being collected, improve modelling techniques. Can we improve some of the confidence around these decisions we're making? And I think that the River Murray salinity modelling is a good case in point, in that the investment made over time in a number of models, you want to see that these things are improved, are upgraded. The other thing to keep in mind is that new questions are coming up. So questions around climate change projections are an example, where you can use the same tool to address some of these questions, or modify an existing tool to try and address other questions that are coming up. Of course, the modelers out there would be horrified that you just take a model and use it for something else. So there's obviously a great deal of work required to look at the assumptions, the limitations of what's been done to address new questions. So this warehouse service, really its objective could be summarised with these two areas. One is to increase the longevity of these assets, and the other one is to make sure we can actually find them. So you can imagine over time, with people coming and going, there's a lot of work being done and it's put somewhere, someone's C drive, or by the way, this isn't my garage. a lot of work is done by consultants. Is that work brought in when a project is finished? So this ability we have to take work that's done in the past and be able to find it again is what we're trying to achieve here. To do this, the groundwater group has put a lot of work in over the last 5 or 6 years, and they've developed a number of guidelines, processes. So this very busy diagram shows you the archive itself. So we have the actual models which are stored in the system. At the moment we're looking at bringing in a number of other models from a number of other disciplines. The locating where these models are, what the domain is, having a database of metadata relating to each model, what platform they were built in, what year, who's the current contact person for this model, and where do we find the reports that relate to this bit of work. So that, I guess, the green is the central repository of this service. Then you have these guidelines which describe how to use the service. So we have guidelines around the actual development of models. So guidelines around how do you take something out of storage, who can make these requests. So there's a number of guidelines which the team have developed to facilitate the use of models developed by the department. Even the review of work being done, so this peer review process. This work by the department has actually been inspirational for the national, maybe not inspirational, but it's had some influence on the national groundwater guidelines that were put out in 2012. And then on the other side you have the people who actually do it. This is all very nice and well unless you have someone to actually operate the system. So we have, when a model is complete from a project, someone who actually will ensure that it's put into this system, who actually does some of the modelling, the capacity of the department, or consultants who work with the department. The process of reviews, which is often as part of the service that's required, and requests that come in for use of these assets. Once they're more visible and discoverable, then people start to want to use them. So this website, I was just looking at this amazing paper up in the gardens where we just had morning tea about knowledge systems of the department, and apparently this website where you can see where all these models are had 1,100 hits last year. So I don't know if that's good or bad. Doesn't seem like much to me. But you can go here and see which part of the state has some work that's been done on it. Click on one of these boxes and look at a description of that model, some of the reports which you can then go and download and read. So I've just come to the last part of this presentation, which is on the current expansion of the warehouse. So the 60 models which are contributed from groundwater, at present we're looking to expand that to include a large number of models from surface water, models which have been done by various ecological models, and there's a partnership which has been established with the Goiter Institute, which is to bring in a number of products or the outputs from a number of projects which have been done under the banner of the Goiter Institute, to make these more visible to the community of practitioners. And so this is a considerable amount of work which is going on at present. And one of the drivers behind this is to comply with the state government's Declaration of Open Data. So in summary, this service provided by the Department of Environment, Water and Natural Resources, its objective is to extend the longevity of models as knowledge assets and make them more discoverable. And you can find more information on this website and by contacting the science unit of the department. Thank you.